So we just did 3 examples of finding intervals of convergence. Our first example converged on the interval from 3 less than equal to x less than equal to 7. Our second converged from negative infinity to infinity, and you can have either kinds of notation here. Then our third converged only at x equals 3. So these aren't the graphs of those functions, but just to give an idea of what's happening. This graph, or this series, only matched our function on an interval. So that's like saying our graph came up, it didn't match, it matched for a while, and then it shot away from the function while this one might be going back up. So it matched for a while. So what that means is you could use this series to estimate the function in this interval but not outside of the interval. For our second example, the series converged from negative infinity to infinity. So it actually matched the function. As long as you did an infinite series, it matched for all terms. So you could use this series to estimate and actually get a really good answer for the function itself. For our third example, it only converged at x equals 3, and let's say that this is x equals 3. That means they were the same at x equals 3, so maybe it was a tangent line. But as soon as you leave x equals 3, the series and the function are not the same at all. So those are the 3 scenarios that you can have. For one of them, the limit you took actually equaled a number, which lets you solve this. For the other, the limit equaled 0, which meant that we were converging everywhere because 0 times something was always less than 1. For the last one, our limit was actually infinity, and the only way to get it to converge would be to have a number less than 1, which meant that infinity had to be multiplied by a 0. So those are your 3 scenarios that you can have.